Yeah, can you hear me?
Yeah. All right.
Okay, great. Thank you.
Yeah, we are the power team for Design 2, or Design Team 2.
Alright, so this is our power system. It consists of 2 different size gear and a handle. So you spin the handle in a circular direction, and the first gear, the small one here, transfers energy to the big gear, and that big gear is connected directly into the barrel.
I guess, very sorry to interrupt. Yeah, the glare is quite a lot. Is it are you projecting from a computer, a PowerPoint?
Yes.
Is this through, and then Dita, is this through your computer or someone else's? Because with WebEx, if it's from your computer, you should be able to share the slides through WebEx with me.
All slides. Should I share that?
Yeah, just you play you.
Okay.
So he can just watch.
Yeah.
So for instance, by chance do you have the slides on your computer?
Yes, I do.
Okay.
And I can update those for you in real time as we update on this one as well. Because
Okay.
we're running 2 separate computers.
Okay, so we can maybe one person.
Yeah, I'll hit that one when we move it. And then
Can you see the screen?
Yeah, I can see it great.
Okay,
Yeah.
so one.
And so what I see, what the screen that I see right now, so I see your projection, and then on the I see design review number 3, team Andrew, Ernesto, Ryland. Got it.
next slide.
Thank you.
Right,
Sorry about that.
Next slide. Oh, no, I'm sorry.
We need to
Are we okay? So we're moving on to. Okay.
So how the handle works is it has a spline that's removable. So we can have adjustable handles, or when they wear out, we can add in new ones.
Alright, so this box was kind of designed to be mounted to anything that can be flat, and then as long as the crushing, whatever is doing the crushing, as long as that can be powered through a rotational movement, that will just connect to that. So really it's designed to kind of be a universal interface with whatever any other team comes up with, like I said, as long as it can mount to a flat wall and then can be connected to whatever is powering the crusher, or whatever is doing the crushing.
Oh, and then the variables the important variables that we have in it is the hand power to crank it, the gearbox top and bottom so the gears aren't exposed and nobody's getting their fingers in there, and then the spline for the shaft removability so you can remove the crank and just have that for mobility and stuff, and then the handle size is going to be appropriate for everybody to use pretty much.
So we will have 2 gears. The bigger one will be 10-inch in diameter, and the smaller one will be 5-inch in diameter. And the bigger one will have 50 teeth, and the second one will have 25 teeth. The bigger one will be attached directly to the barrel, and the smaller one will attach to the 1 feet handle. And the total force required to break the rock will be 50 fluid pound.
And so, I believe Team 1 did an experiment where they found that it takes about 240 newtons to crush rock, or about 50 pounds. And so with our 1 foot handle and 1 to 2 gear ratio, we found that at a minimum it'll be about 12.5 pounds per handle, because we'll have this mirrored on each side, so we'll have 2 of these gearboxes. So we found it'll be about 12.5 pounds minimum to crush the rock, but we're assuming a value of 25 pounds for each side. And here is the FEA analysis. This is just where the stress concentrations are. So you can see on the handle, the stress is concentrated down at the bottom elbow and also at the teeth of the spline right up here. And then also on the gear, the stress is concentrated on the actual teeth of the gear.
Alright, so here we have our FMEA, which is the failure modes and effects analysis. So the few things that we have are the gears, the crank, and the gear shaft. And so the functions of them, pretty self-explanatory. Like the gears rotate and that turns the barrel. A couple more things you got on the next page. The fasteners, the gearbox, and the splines, as explained earlier. Some potential failure modes, for example, are like on the splines, could be fracture from too much force, or creep or corrosion. Alright, so our top three risk priority numbers that we came up with are the gear shafts. So that came out at a 126, and one thing that we came up for that was we could maintenance that every day, and we could check the shafts. So that way you're just doing a check to see if there's any kind of fractures or anything that would cause any safety concerns. Then we have the crank. So this came in at a 96, and one thing that we came up with is that we could have a spare crank on hand, because if the crank breaks, then your machine's pretty much inoperable and you can't turn the power device, and then the barrel will turn to crush the rocks. So if you have a spare crank on hand, then you'll be able to replace it easy. And then we also have the gears. Those are important, because if those stop working, then the barrel won't turn. So you can just maintenance these daily and use lubricants to help them turn easier.
So, moving forward with our current design, the price after we got to looking at it was going to be somewhere above $500, which is obviously going to be too much. And the current weight with the 1020 steel is going to be around 300 pounds, which obviously is not very economical or portable. So moving forward, we're going to look into the same design, playing with the sizes of the gears, changing the types of metal, so maybe the case doesn't need to be 1020 steel, or removing material, so taking little parts out of the gears to make them hollow in the middle, because they don't necessarily need all that. We've also talked about, instead of having power on both sides, having just power on one side, effectively cutting the cost in half. And ultimately, if none of those changes work, we would end up doing a redesign as a whole to meet the criteria given to us. Any questions?
Thank you. That was a nice presentation.
Thank you.